back to last week, Thursday, we started factoring polynomials. So remember, your first step is always to do greatest common factor. After you do the greatest common factor, then where you go next is based off of how many terms you have. If you have 2 terms, then it's either difference of 2 squares, sum of cubes, or difference of cubes. 3 terms is MAF, which is what we'll be doing today. 4 terms, or an even number terms, so 4, 6, 8, etc., we use grouping. And grouping is what we'll be doing tomorrow. So on Thursday, we did greatest common factor and sum of cubes, difference of cubes, and difference of 2 squares. So now we're going to move on to MAF. So now we're going to move to MAF. So MAF is for 3 terms. Anything that has 3 terms uses MAF, or has the possibility to use MAF. So in general, MAF can be used if you have x squared, because you can separate it into x times x. But you can also use it with x to the 4th, because it can be separated into x squared times x squared, or x to the 6th, which is x to the 3rd times x to the 3rd, and so on. I'm pretty sure you can pick up the pattern. But the main thing is you must have 3 terms. That's a not negotiable. You've got to have 3 terms to make this work. So, with MAF, so we have x squared plus 17x plus 60. So we're trying to rewrite this problem in 2 sets of parentheses. We're trying to rewrite it in 2 sets of parentheses. So the M represents taking the first term and the last term, multiplying them together. So the first term has a coefficient of 1. The last term is 60. So 1 times 60, 60. The A term is simply the middle term, 17. So the F is where all the magic happens. We need 2 numbers that multiply to 60, but add up to 17. So there are 2 numbers that multiply to 60 and add up to 17. It has to do both. It has to do both of them at the same time. So the only number that works, 12 and 5. 12 times 5 is 60. 12 plus 5 is 17. Any questions before we continue? If you have a question, you can type it in the chat or come off the mute and say something. So, once you get your 2 factors, you divide them by whatever the leading coefficient was. So that's 1. But if I divide by 1, none of that changes. So our answer is x plus 12 and x plus 5. So that's your factor answer. So, one key thing is, well, how do I know if I get it correctly? If you take your answer and multiply it out, you should end up back where you started. If I take this answer and multiply it out, you should end up back where you started. Now, you don't have to show that you did that, but you should be able to take your answer, multiply it out, and go back to where you started. But that's it. That's all for that problem. Any questions with example 1? All right, seeing none, hearing none. Let's go to example 2. So example 2 works very similarly. 9x squared minus 12x plus 4. So let's start with our m. First term is 9, second term is 4. 9 times 4, 36. The a is whatever the middle term is, negative 12. So the f is where the magic happens. We need two numbers that multiply to 36, but add up to negative 12. Remember, there's only one combination that's going to work. Any guesses on what that's going to be? Any guesses on what the winning combination is going to be? Two numbers that multiply to 36 and add up to a negative 12. So, negative 6 times negative 6. So both of them need to be negative. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. So there's our factors. Since your leading coefficient was 9, we divide them by 9. So that gives us negative 2/3, negative 2/3. So our factors are x minus 2/3, x minus 2/3. Now, there's one last part. We cannot leave these as fractions. So you can't leave those two numbers as fractions. So this is how we take care of it. Very simple trick. Take the denominator, move it in front of the x. Take the denominator, move it in front of the x. So x minus 2/3 will become 3x minus 2. Same thing for the other fraction. And there's your factored answer. So, key thing here is you do not want fractions as your factors. You don't want your fractions to be your factors. We need to move them, we'll move them. Rearrange them. Any questions with example 2? Any questions with example 2? And if you got them, don't be shy. Let's see, if you do have them, you may have to just turn your mic off, turn your mic on, and just say them, because I may not see your hand. Since I'm always moving around. Check the chat real quick. Make sure there wasn't any questions up there. Nope, looks like we're good to go. So let's keep it moving. example 3. So, like I said, the variable does not have to be x squared in order for you to do MAF. Notice that we have x to the 4th power. Remember, x to the 4th, or u to the 4th in this case, can be broken up into x squared, well, u squared times u squared. Since you have u squared in the problem, we can still do MAF. So if this was u to the 4th and just a regular old u, we couldn't do MAF to this. So it would have to be u to the 4th and u squared. So this is still MAF eligible. So for the m, 5 and negative 6, 5 times negative 6, negative 30. Your a value is simply your middle term, 13. So we need two numbers that multiply to negative 30 and add up to positive 13. Any guesses? Negative 30 and positive 13. 15 and negative 2. 15 times negative 2, negative 30. 15 plus negative 2, and 13. So we got what we needed. The leading coefficient was 5, so divide both parts by 5. So 15 divided by 5 will give us 3. So one of our factors will be u plus 3. Negative 2 over 5 cannot be reduced. So this factor is going to be u minus 2/5. So remember, we can't have the fraction as a factor. Take the 5, move it over. So this says u and u. U times u would give me u squared. We need u to the 4th. So just raise them to the 2nd power. So hopefully you're noticing it becomes a lot more detail oriented the harder the problem gets. So you really have to take that extra 5 to 10 seconds and really pay attention to what you're doing. It's not a difficult problem, but it is one that you're gonna have to pay attention to what you're doing. Any questions with example 3? All right, so we'll do one more example with example 4, and then I'll open up the floor. We can do another example of any of the 4 types that you've seen that you wish. So example 4. We have 3x squared minus xy minus 2y squared. Now notice we have multiple variables. That means when we write our answer, you're going to have multiple variables in your answer. So you're going to have an x and a y somewhere, and you're going to have an x and a y somewhere, instead of just a variable and a number. So just keep that in mind as we go along. But m is still the same. First number was 3, last number was negative 2. 3 times negative 2 is negative 6. A is the middle number, which is negative 1. So we need two numbers that multiply to negative 6 and add up to -1. Any guesses? -6 and -1. -3 and +2. -3 times 2, -6. -3 plus 2, -1. Leading coefficient was 3. Divide by 3. So you have -3 divided by 3, -1. So that means one of your answers is going to be x minus y. Now, the reason why x came first, we started with the x. The reason why y is second, ended with a y. Two-thirds can't be reduced. So that means you have x minus 2/3 y. But you don't want a fraction as a factor. Take 3, move it over. So your final answer is x minus y and 3x minus 2y. 3x plus 2y, basically. So again, if you have multiple variables, go ahead. So -1 is still right there. So 1 and -1, the number 1 is almost always never going to be written as a coefficient. It's understood to be a 1. So again, if you have multiple variables, then you simply set them up in the order that they were presented in the problem. So since x came first and y came second, that's why x is first and y is second. So there's no real mathematical reason for that. All right, questions on problem 4? All right, so let me open up the floor for any additional examples. Any examples anything you want to see another example of. For example, if you want to see another example similar to example 1, now's the time to ask for it. Or another example like example 2, now's the time to ask for it. Right now, the floor is yours. All right, so we're going to do an additional example with multiple variables. So this problem is going to be the following. So example 5. 10x squared minus 3xy minus 4y squared. 10x squared minus 3xy minus 4y squared. All right, so same rules apply. We start with our m. First term was 10, last term's -4. 10 times -4, -40. A value is the middle term, -3. So we need two numbers that multiply to -40 and add to -3. -8 and a +5. So those will definitely work. leading coefficient was 10. Divide both numbers by 10. So negative 8 over 10 reduces to negative 4/5. So this would write itself as x minus 4 over 5 y. Remember, since x came first, y came second, that's how it presents itself in the answer. 5 has to move over. 5x minus 4y. Second factor. 5 over 10 reduces to 1/2. So you have x plus 1/2 y. Same thing occurs. 2 moves in front. 2x plus y. And that gives you your factor answer. So, any questions with example 5? Alright, I'm actually going to add one more example in there to finish us off today. And this is going to be an example that requires us to take out our greatest common factor first. So this is going to require us to take out the greatest common factor first. So the example that we are going to look at will be y to the third minus 4y squared minus 12y. So, taking out a greatest common factor should always be the first thing you look for anyway. Before we start any problem, you should always look at it and see, can I take out a greatest common factor? What can I take out of all three terms?
Y.
You can take out a y. So we're going to divide y out of every single term. Now some of you might be thinking, well, can't I take out a 4? That works for those two, but it doesn't work for the first term. It either has to work for everything or nothing at all. It's an all or nothing type deal. So if we take out a y, you're left with y squared minus 4y minus 12. So for the y that we took out, that's done. There's nothing else we can do with the y that we just took out. But for the rest of the parentheses, we can attempt to do MAF. So M, first term's 1, last term's negative 12. 1 times negative 12, negative 12. The A is the middle term, negative 4. So we need two numbers that multiply to negative 12 and add to negative 4. Any guesses on those two numbers? Negative 6 and positive 2. Negative 6, positive 2. Excellent. The leading coefficient was 1. But if you divide those by 1, nothing's going to change. So that means you have y minus 6 and y plus 2. And that is your final factored answer. Notice that the greatest common factor is included in the final answer, so it has to be included. So, other than that, any questions on examples 5 or 6?